So I was mentioning about converting the textual data into one hot encoding vector, right? So what is one hot encoding? It is the simplest way of converting the textual or the verbal data into numerical data. So what we generally do, we will convert or assign values 1 and 0 to the present or non-present data. So this is a just overview which I told about how a one hot encoding will be looking like. So here I will taking this context as an input to my shallow neural network here. So it is called as shallow neural network because it has only three layers: one input layer, one hidden layer, and one output layer. So here the input neurons are deeply connected to hidden layer, and a specific number of networks or neurons are connected to the output layer. So my task is to input this context into the neural network and get a certain output. So for that, I will consider the context here. So the input to this neural network will be looking like will, right? So this will be converted into one, whereas other vocabulary words such as what and be will be marked as zero. So it will be looking like 0 1 0. This will be fed into this neural network, and we can easily predict that the output shape will also be the same, but the values will be different, right? So here I am feeding this input in this form, right? So I am feeding 0 and 0 and 1, right? So I am expecting this neural network to predict these two contextual words based on the input word. So the neural network will understand what are all the input neurons should to be activated for the particular input, and it will give me the predicted output. So by doing this with all the different context and with a set of different examples, then my neural network will able to understand the weights associated with each of the words, and those weights are learned or present in the hidden layer. So the hidden layer which is generated after a large amount of training will be the word embedding. The word embeddings which I am going to generate through the probabilistic based approach will be nothing but the weight associated with the neurons in the hidden layer. So I will just take another example in order to better explain this whole concept of shallow neural network and converting the alphabets or the words into one hot encoded vectors. So I'm taking an example of I think, therefore I am as a sentence, as one of the sentence. Fine. So now for the neural network, this is how it will be looking like. So it has a one input layer, one hidden layer, one output layer, and as I told, each of the input will be associated with the hidden layer neurons, and it will understand the weight associated with each of the connection between the input and the hidden layer. These weights will be learned by the network, and after a large amount of training, we'll be ending up with a well trained hidden layer with a particular weight associated with it, and we will take out that hidden layer or use it as a word embedding. So I'm taking this example, I think before I am. So if I take the word think, then I want my output to be I and therefore, because these are the two nearest neighbors, right? These are the contextual words where this where this word think appears. So when I try to pass this as an input, then the one heart encoded vector will be looking in this form, because I want all the other things to be 0 and only this think word should be 1. So it will be 0, 1, 0, 0, 0. So the neural network should be yielding or predicting the context words which are nearest to the word think, right? So the output expected would be of two types or the two context. One, let me just take the first case where the left word or the preceding left word as 1. So it could able to successfully predict the one of the contextual words, that is I. So the output would be in this form 1 0 0 0. And another case, that is the right preceding word, right? So the right preceding word would be looking like 0 0 1 0 0. So my final output of this neural network, my final output would be combination of these two different cases, right? Because if I pass this word thing, the output should be I, and therefore it has to yield both the outputs, right? So after combining these two contexts or these two different cases, the final output would be looking like this. So it will be 1 because I, that is this case, sorry, this case I, 0, therefore that is this case as 1. Then again there is no word called as I in the input, right? So that is 0, then am and 0. So in the neural network it is clearly shown, right? So I am passing this word think as a one heart encoded vector. It is connected to the hidden layer through different weights associated with each of the connection. This weight will be learned or trained in the hidden layer. Then it will be predicting an output in this form. So the output which I mentioned here, that is 1 0 1 0 0, that would be the output which I am predicting at the end. So it is clearly shown that it will be predicting one as I and another one as therefore. So as soon as I pass this word thing, I will be getting the contextual neighbors as I and therefore. So this is just an example of a single context or a single sentence. So we will try to train this neural network or a shallow neural network with many such these examples. So we will try to create examples or sentences in this similar way, and we'll make the neural network to understand the weights associated with it. So we'll basically make the network understand that, so if a word think is appearing based on a given sentence, then what are all the weights or what are all the circumstances where this thing can be appearing. So once the final training or training of the neural network with large amount of data is done, the hidden layer is very much ready to use it as a word embedding. This is a brief idea or a brief explanation on how to generate a word embedding using Skipgram method or prediction based approach.